Welcome back to Swell Academy. Today we're talking about writing an equation of a linear function. In the past we've talked about slope-intercept, which is y equals mx plus b. That's your slope-intercept. Now we're going to kind of discuss some of our point slope. And the reason it's called point slope is more so you're using a point or a coordinate and you're including your slope. And that one we want to remember is y is equal to, or y minus y1 is equal to m x minus x1. And simply we have our x1 here, we have our y1, and we have our slope. So all we need to do is kind of just plug in accordingly. And we have y minus 0 is equal to 5, x minus 1. You'll have to distribute y is equal to 5x minus 5. And here we have our linear equation, our linear function. They want the linear function to be in that y equals mx plus b format because you have the dependent variable by itself, y, and it's a function of x. Another thing to look at is technically you have your y. If we're looking at y is equal to mx plus b, technically you have your y, which is 0, you have your slope, which is 5, you have your x, which is 1. So you could actually, instead of using point slope, you can use your slope intercept and solve for your b, which in this case would be, 0 is equal to 5 plus b, subtract both sides by 5. My b is equal to negative 5. So if I have my b or y intercept and I have my slope of 5, then I could just plug in the negative 5x. Oh, I'm sorry, positive 5x for the slope. Minus the 5, here was your m, and here's the b that we plugged in. So, two separate ways of solving, each will work, it just depends, on the problem, and so on and so forth. You will end up with a question, though, which doesn't have your slope, and what we need to do is refer back to our slope formula, which is y2 minus y1, x2 minus x1. Now, technically, it doesn't matter which one is your x1 or y1 coordinate, but I just like to list it in order, and I just kind of stick to that routine. And you get negative 10 minus a minus 10. Don't forget you're doing a minus, so a lot of times students will put minus 10, minus 10. And then you end up with negative 1 minus a negative 2. And if you look at this problem here, actually you end up with a 0 on top. So this is something with no slope. You end up with a 1 on the bottom. And then you would take your point slope. You can use either coordinate. I would probably use the one with the negative 1 in it. Maybe that's an easier number to work with. And I do y minus my negative 10. So I'm putting this here into my slope intercept. I have my slope of 0, x minus negative 1. I like to rewrite this as y plus 10 is equal to 0, x plus 1. Looks a little easier to work with. The 0 is going to distribute, and you end up with y is equal to negative 10. This we call no slope. Don't forget, if you have 1 over 0, we know it's a vertical line, but we're not sure if it's positive or negative, so we like to call that undefined. Let's just take a look at a quick one where you would actually end up with a slope. Let's say you have 0, 4, and 1 end 5. So you would just do 5 minus 4 over 1 minus 0. And you end up with a slope of, let's actually make the slope 3. We'll make it 2. I want to show just like a number and have a fraction. So 5 minus 2, 1 minus 0, and you end up with 3 over 1. This is what you would use as your slope. So then you would have, now again, I like to use this coordinate with the 0 in it because it makes my distribution easier. Y minus 2 is equal to, I can just call this 3 or 3 over 1. x minus 0, and I end up y minus 2 is equal to 3x, add the 2, y is equal to 3x plus 2. And also just consider, again, you may end up, let's say I worked out my slope, and my slope ends up being negative 1/2. And one of my coordinates I used to get that using slope formula was, 4 and 6. You may have to work with a fraction, and just make sure you distribute your fraction in a way which you get negative 1/2 x, and then a positive. You're going to do negative 1/2 times negative 4/1. That's how that's working. Negative is a positive 4/2, where you end up with 2. So just make sure when you distribute that negative, you're following suit and you're using math principles. We'll add the 6 to both sides, and we'll end up negative 1/2 x plus 8. So those are just a few things to consider. Again, just make sure you're solving for your slope first, and then pick either coordinate. Usually I like to pick the ones with 0 and 1s in it. It makes some of this using point slope a little bit easier. Let's just go back. Final problem with little, maybe bigger numbers here. You have 11 and froze a bit. You have 11 and 20 here. Let me just look at this. What would this end up being? Negative 11 minus a minus 12. Again, I like putting the parentheses. I like putting the minus and then putting the number. 20 minus 15. This ends up being adding. Negative 11 plus 12 is 1. So you get the 1/5. And here we have a fraction. Now, I know I'm going to distribute this 1/5 to this number here. So I want to use a number that works with 5. Now, both 15 and 20 are going to work with 5, so I'm okay there. We could use the even number here. So let's just use this coordinate. And if I plugged in either, if I did y, well, let's look. If I did y minus a minus 12 is equal to x minus the 15, or if I did y minus the minus 11 is equal to 1/5 x minus 20. If I do either, maybe I should show you that. So let's look at that. Y plus 12 is equal to 1/5 x minus, basically you end up with a negative 15/5, which is a negative 3. Subtract the 12. And it's actually, if you do both, it's a good way of ensuring you have the correct answer. So if I'm looking at this here in blue now, y plus 11 is equal to 1/5 x. I end up with a negative 20. Over 5. I was just checking my work from the previous, which ends up being negative 4. And if I'm minus 11 from both sides, notice I end up with the same y equals mx plus b with a slope of 1/5 and the y-intercept of negative 15. So both actually worked for me in either case, and that's what you're working with. Hope this is helpful. I'll see you guys soon.